Recently, Nobel Prize in Physics is awarded to 3 scientists for work exploring quantum weirdness, or quantum entanglement. Alain Aspect, John F. Clauser and Anton Zeilinger were recognized for their experiments in an area that has broad implications for secure information transfer and quantum computing. Also, this discovery has given rise to many possibilities, which was earlier science fiction. Before moving on to this discovery, let us understand a little about the history of this discovery. Quantum mechanics arose in the early decades of the 20th century, a period often called the Second Scientific Revolution, as scientists tried to understand the inner lives of atoms. Its centerpiece was the uncertainty principle, enunciated by Werner Heisenberg in 1927, which states that certain types of knowledge of a particle's position and velocity, for example, are incompatible. The more precisely one property is measured, the blurrier and more uncertain the other becomes. Einstein, though one of the founders of quantum theory, rejected it, saying famously, "God did not play dice with the universe." Quantum entanglement, a prediction of quantum mechanics, says, if we measure the properties of 2 pairs of quantum particles, then measuring one particle in one place can immediately affect the measurement of another particle, even if it is millions of miles away. It feels like information travel way faster than light. Such phenomena were the subject of a 1935 paper by Albert Einstein, Boris Podolsky, and Nathan Rosen, and several papers by Erwin Schrödinger shortly thereafter, describing what came to be known as the EPR paradox. Einstein and others considered such behavior impossible, as it violated the local realism view of causality. Einstein referring to it as spooky action at a distance, and argued that the accepted formulation of quantum mechanics must therefore be incomplete. But thankfully in 1964, John Stuart Bell gave a theory called Bell's inequality, with the help of which we could experimentally test the predictions of quantum mechanics. Stuart Bell said, "The Bell inequality, which if violated in real experiments, means that quantum mechanics violates locality or realism." Experimental tests of the Bell inequality, beginning with Alain Aspect's 1982 experiments, show that quantum mechanics seems to violate the inequality, so it must violate either locality or realism. However, scientists have noted these experiments included loopholes, which prevented a definitive answer to this question. Previously, in 1972, using duct tape and spare parts in the basement on the campus of the University of California, Berkeley, Dr. Clauser and a graduate student, Stuart Friedman, who died in 2012, endeavored to perform Bell's experiment to measure quantum entanglement. Dr. Clauser found that the results of his experiment could neither be understood by classical physics nor by Einstein's laws. Something strange is going on in the universe. The entanglement seemed real. At the time, most physicists weren't interested in arguing about the meaning of quantum mechanics, as they were busy using it to build atomic bombs and transistors. David Kaiser, a professor of physics and the history of science at the Massachusetts Institute of Technology, said, "Clauser got a lot of pushback from scientists who didn't think this was even part of science." In an interview with the American Institute of Physics in 2002, Dr. Clauser admitted that he himself had expected quantum mechanics to be wrong and Einstein to be right. "Obviously, we got the wrong result. I had no choice but to report what we saw. Here's the result. But it contradicts what I believed in my gut has to be true." He added, "I hoped we would overthrow quantum mechanics. Everyone else thought, John, you're totally nuts." But there were still more possible loopholes in the Bell experiment that Dr. Clauser had identified, and which needed to be closed before quantum physicists could declare victory over Einstein. For decades, each had left open at least one loophole, by which it was possible to question the validity of the results. However, in 2015, an experiment was performed that simultaneously closed both the detection and locality loopholes, and was heralded as loophole-free. This experiment ruled out a large class of local realism theories with certainty. Finally, experiments conducted over the last 50 years confirmed the reality of an effect that Albert Einstein had disdained as spooky action at a distance. Measuring one of a widely separated pair of particles could instantaneously change the results of measuring the other particle, even if it was light years away. Einstein may be wrong this time, but still it was Einstein who brought this weird behavior of the universe in front of everyone first. 3 physicists, whose works in these experiments showed that nature is even weirder than Einstein had dared to imagine. For this amazing discovery, they have been named winners of the 2022 Nobel Prize in Physics. One of the Nobel Prize winner, Dr. Clauser, said, "Entanglement seemed real, but it could not be used to communicate information faster than the speed of light. But it has broad applications in quantum computing and an upcoming quantum internet, to the tune of more than $1 billion a year." One of its first successes in cryptology is messages sent using entangled pairs, which can send cryptographic keys in a secure manner. Any eavesdropping will destroy the entanglement, alerting the receiver that something is wrong. With the help of this quantum weirdness, maybe in the future we will be able to send information far away in the universe way faster than the speed of light.